Hello and welcome back to Compiler Programming. Today I want to talk about the syntax of the math language, and when I started the project I just took whatever syntax I thought was looking pretty decent, took it from some other projects and just put something together so we have a syntax that can be worked on and can get us to where we are right now. However, it is very much a provisional syntax and there are now quite a few things that I'm not exactly happy about. One of the big ones is that there is no real way to define whether a value is a constant or not in this particular syntax. So there is this double colon stuff which is supposed to mean more like static kind of thing in C world. It is also const kind of, but yeah, in Jai language, where this more or less comes from, this means declarative scope, but there is no meaning for that in this one. So yeah, I want to have explicit const stuff. I also not sure that I like this thing where sort of I just want to declare a variable on a stack. It is kind of implicit, where does it go and so on. So yeah, I want to have something else, and today I just want to experiment with the syntax, and at the same time I want to stress the current macro system, because what I want to do is I want to take this function, I want to convert it to some new syntax that I have some ideas about it, so we'll try to flesh it out, but I want to implement that new syntax entirely in the macro system. So I don't actually have to change any internals of the compiler for now, and see how that works out. So first, let's start with the syntax itself. So we have this function. I'm just gonna try to convert this one. And the first thing I think that I want, and the first annoyance that I want to fix internally to the compiler, is how we deal with the functions. And one of the problems with the functions is in the recursive definition, right? So if you have some function foo, and that function foo needs to call itself, that means that at the point where we parse the body of the function, this declaration needs to be already processed. So the way that it's handled right now is that I sort of split the function definition in two parts. I first only do the header of the function or declaration, I don't know how to call this, and then I bind that to some binding, and then I try to execute or resolve the body. I don't think that's very good. It's pretty much a hack, and would be nicer if a function had an internal name. It also is helpful in cases, like in debugging cases, if you assign a function to a variable. So let's say you have something like bar is a function that returns 42, right? So, and then you assign this to bus, you say that bus is bar. So now the question is, if there is an error in the function called bus, what will the user see reported? Like, is it going to be called bus? Is it going to be called bar? Is it just going to be anonymous? So all of that is not exactly great. So it would be nice if you could give functions names, but it's just not a thing with the current syntax. I was thinking for a while how do I do that, and I couldn't come up with anything really good. Also, because current syntax sort of relies on this arrow to be present for parsing, getting rid of it for cases where we don't have any return values is possible but awkward. So in a sense, that is also just kind of annoyance. after thinking about it for a bit, I think I will go with a more, I don't know, Rust-like approach or whatever, where a function starts with a function keyword. It also makes parsing much easier. Not that it really complicated here, but it's just, you know, something. It's not actually easier. It makes parsing more efficient because once you come up to the keyword, you already know that you're going to be parsing a function. But it doesn't really affect the complexity. It's just speed in a sense, because you don't have to look ahead. Anyhow, so you have function, and functions can be anonymous. So I can say x is s64 x, right? So s64, and there is a question whether these parentheses are required or not, but I'll think about it as a separate sort of topic. I can also decide to change this to a colon, but I kind of like arrow more. It's more explicit what's happening. So yeah, this would be an anonymous form of the function, so I could probably like substitute it here. But I would also like to have a named version, and a named version where the name would just go here. And as I said, that means that if we have a recursive function, so something like foo of x minus 1, that is also very straightforward, which sort of name is going to be used for this, and how to refer to itself, even if I decide that this is actually going to be assigned to some other variable. So yeah, this is the basic change that I want to do with the function. If the function doesn't return anything, it also should be pretty straightforward to parse it now like this, where you just omit this arrow and then return values. And I guess we can start from there. So let's try to make that change. And as I mentioned in the beginning, I will try to make that change with just the macro setup that we have already. I'm not sure it will work out. Actually, I'm pretty sure it will not work out, but that's something we can take a look at. So I will say function print, and we will go like this. And I also want to get rid of this version. Right. Cool. Now we can go to Prelude, and we can grab one of the statements that we can work on for this to happen. So it is a syntax. It says a statement. So it means that it kind of encompasses the whole line and not just a sub-expression. Then we have our function. Then we have a problem because right now syntax stuff does not have optional measures, and I'm not exactly sure I want to have optional measures because they will increase the complexity of matching. But we'll see if that's a thing. For now, I will just have to do 2 versions of this, I guess, but that's okay. So I think we have a function, then we have I don't also have a match. I don't have a way to directly match against an identifier specifying that that's what it should be. So for now, that's going to be just dot, and we will call it name. Then we are going to have braces, right? So name braces, which is args, like this, at args, and afterwards we would have braces and body. So this is a version of the function with a name, but with no return arguments. Let's think about what it will do. It will be the following. Actually, now that I'm thinking about that, I think we are currently not gonna support support this because you cannot do a declaration inside of a syntax thing, maybe. But well, let's just see where we fail and decide where to go from there. Okay, what it will be? Well, it is name, right? And then it will be like so. Then we would have args like so, and body. So this is something like what we would like it to happen. However, I don't think this will work. So we'll have to do some adjustments on how syntax statement implementation is happening, or we'll have to introduce a new type of syntax definition. We'll see. If I try to run the tests, we will probably fail miserably. Yes, it says that it could not parse a top level statement. I expected this kind of error, and this kind of error happens because no, couldn't parse it. Yeah, it happens because we have this special mode for top level, and I think I want to get rid of it because in the end, top level is kind of just same as any other block in the program. So we can try to do it that way and see if that actually works out. So we are going to do token parse block no scope. We need to have context. It actually needs to have a block which we don't really have. But I guess let's try to cheat a bit, and we'll say token fake block, or rather token star fake block is allocator allocate context allocator token, and we would fill in our fake block with data. That should not be a problem. So tag is token tag group. Then we have source, which is kind of just a textual representation of this token, so it's nicer to print. Actually, it's mostly for debug, but we can grab it from information where the token starts and ends. And this also is the same thing. And finally, we have information that is special to group tokens. And group tokens are these kind of curly braces and parentheses. So tag is token group tag curly. Yeah, that sounds good. And we have children, which is view. Right. So we pass a fake block and it wants a result, but we don't need one, so we'll just say that it's a void value. I need to say token here. Okay. And this function wants an ampersand. Good. This thing needs to return a value. That's fine. We will just say return context result. So this actually is now gonna destroy a bunch of tests. So before we proceed any further, I will actually undo this file and we will see if it works in the original state. I don't think it will because we don't have this operator definition stuff or exports actually available to us. How do I make that work? I guess for now I'll just allow it in any block, and then we will deal with the fallout of this later on. Okay. Token parse exports and token parse operator definition, right? So you need to have value star unused result and void star unused data. In C sadly you have to provide the names even if you don't use the stuff, so that's kind of annoying. Okay, so that was parse exports, and there is also parse operator definition. Let's change the signature exactly the same. Unused value, void star, unused data. I'm just changing the signature so it matches all our other handlers for stuff. Token parse syntax definition. Yes, you can see there are these we call them statement matchers, and we're just gonna put this into here for now. Does that build? It does not, because these things I need to actually, right, they look slightly different, I think, from what we want. So parse syntax definition. Right. This thing needs to return peak index. So use 64i. Right. Go to error. So here we need to return peak index instead of the boolean. Okay. And basically the same for the parse exports. Go to error, return true, no. This needs to say peak index. If token match. So go to error. And here we say peak index. And this is a U64. Okay, so that builds, but I have no idea if I actually broke anything. We have one failing test, and that is a test explicitly for top level statements. Since we just removed top level statements, that test needs to go away, and we can also get rid of this stuff. Git status, git add source, source spec. So we are at 150. Remove custom code for handling top level statements. Okay, so this actually should help us with the macro stuff that we are doing. And the reason it helps is because if we look at this function, parse block no scope, this is actually where the macro stuff is happening. If I can find it. Right. So yeah, this is where it tries to match statements and macros somewhere in here as well. Actually, I believe macro statements are one of these ones. So it all happens in this loop. So now, if I try to put back our new syntax, I think it will still fail, but we will see what actually happens there. Right. So it says known operator double colon, and this is where it becomes a bit problematic with the way that statements are handled. So they are right now non-recursive. So if I matched this macro, I am not going to try to match any other macros on the nested sort of stuff that is here, which is a bit problematic because this is also defined as a statement, and we cannot really like define a new variable that way. So yeah, that's a bit awkward. I'm not sure how I want to work around this limitation. One way would be to introduce a special modifier, something like saying that this is a different kind of syntax that works in somewhat different way. I could also change how our binding setup works as well. Let me quickly consider what I want to do here. So first of all, what if I do this? I'm kind of curious. What will be the error? To do user error. Okay, line 2833. What is happening here? Right. So we are passing our interesting. So I know what's going on, but I do not know exactly what to do about that. So what is happening is this double colon expects on the left hand side to have just an identifier, but it sees instead a function call, and it has no idea how to handle that. So I think what I want to do about that is actually kind of tricky. First, let me try to see if something like this will work. So obviously it won't work completely, but I'm curious if we can parse the function definition that is done in this way. And I have no idea. So something happened, but that doesn't necessarily mean that we actually did what I think we did. Unknown operator colon. Right. Right. So the issue right now is that this macro system that I have at the moment, it's very hygienic, so it hides whatever is inside of itself, while I want to operate on the level of the tokens and not on the level of values as I'm doing at the moment. Right. Interesting. What can I do? I actually had a previous system that would do expansion on the level of tokens, and I eventually ripped it out in favor of this one, thinking that I would not actually need it, but apparently I do need it. I mean, another way I can try to handle this kind of stuff is I can sort of create more procedural tokens where you would get, like, you would do something like, I don't know, no, whatever, some kind of escaping, and you say args or body, whatever, and this would give you raw tokens here and expand them instead of providing the resulting value. But I don't know. Let's just start working on something like that. Statement. I think I called it transparent the last time it was happening, or whatever. It's gonna be called transparent, and we're gonna have the previous thing where we say name, then we're gonna say args, and we're gonna say body. Right. We also want this kind of thing to be now recursive. So this would be matched against the next level of our setup. So maybe we'll call it transform or something. That could work. Right. So parse syntax definition. This is the function that we are going to work on. Right, we have maybe match statement. We will have now this new transform thing, and the big question is what is going to happen when we do transform. It's still a statement, okay. So if statement, we check it initialized, blah blah blah, And now I guess we check if it is a transform and we do something. Otherwise, we will do what we did before. So, right, token parse macro transform. And let's look at what this thing is doing. And we're just gonna copy that and figure something out. Macro transform. Okay, we are trying to match. We matched. Everything is great. And now the only question is, right, so there is this token apply macro syntax. And this is where the difference will be with what we are doing otherwise. Because this setup, it actually creates like a fake function that we can call, and then the function will be expanded to whatever we want it to be expanded. But this is not at all what we actually want to happen now. Instead, we will be doing some funky stuff with our setup. So let's just do it first in line. I will figure out what will need to happen. We have capture. All right. This gets the name. C. Okay. We will take this. Do we need this loop? Kind of. So let's put this here. And we will need actually a new Hashmap, which we had before, but then I removed it. So let's put this back, Hashmap slice, and we'll call it row macro map, and it will be from a name to token view, I guess. Right. So we go through all the patterns of the macro, and we would need to say row macro map star macro map is hash map make of row macro map. So we get the name, and we also need to have a macro replacement, right? Token capture view, right? So this is the replacement. So this is what we captured. So now we can just say hash map set of macro map. We have the name, which is capture name, and then we have the value, which is capture view. Okay. And for now, I'm gonna do a non-recursive version of this, where what's gonna happen basically is I will just go through the tokens on this top level and replace them with what we want. So we will need to have like an array const token pointer result tokens. Something like that. We also will need to destroy our hashmap. Hashmap destroy, and that would be what's called macro map. Okay. So result tokens, right? So for u64, I is 0, I is less than dynamic array length of macro replacement. Now we get the token. Token star token is wait, is macro replacement right? That's a token view, so we don't need to have that. Instead, this would be macro replacement length, and then token you get macro replacement I, and I would say if token tag is token tag ID. So if we have something along the lines of this, right? So we have a name and we had name here. We are just trying to match those two. If token tag ID, actually, let's just do a filter. If it's not ID, then we add this to the result token array. Tokens and token, right? And then continue. And if it is an ID, we will say slice name is token source. If Hashmap has, or I can actually do token view star, maybe replacement, and that will be Hashmap get of macro map name. If not, maybe replacement, or maybe a replacement, then also continue. Actually, then in both of the cases we need to push, so maybe what we should be doing is actually other way around, and we always are pushing here, and in here we just do it like this. Something along these lines. So if it is an ID and we found a replacement, then we are going to just copy that replacement into the result array. So for u64 replacement index, or u index is 0, view index is less than macro replacement index. Actually, let's call it maybe splice index. And here we will do sort of the same thing, except we are doing it multiple times. And then after we are done, we are saying continue. Right, and then token view get. Actually, it's not macro replacement, it's maybe replacement length. Maybe replacement. And splice index. Right. Does it compile? So surprisingly, that does compile. And let's actually quickly add a panic in here. And I just want to see if we end up in this code at all. We should, but you never know. Maybe I screwed up the previous part. Okay, great. We do end up in this code path. So now we can see if that at all works. Actually, it won't, because I created this array, but I'm not doing anything with it. And what I should be doing with it is I should be treating it as a block. So, or rather, I should be treating it as a statement, kind of. Let's see what we are doing in token parse block no scope, right? So what is happening here? This is rather tricky. So I think what I want to do is I want to take this function and I want to actually split it in two. This first one will be token parse block view, and instead of block, it will accept a token view children view. Right. Now we can remove this stuff, and then in here it will just call to this version. So you don't even need these, I think. We are just saying context, and then we are saying block group children and block result value. Something along these lines. And the reason I'm doing that is because it'll actually help us with that top level thing, because we won't need to create a block. And it should also help us with this new one as well. So that's good. Now I just need to take this thing and put it somewhere over here, so I can actually call this. And result value, yes, we have that one. So we can say token parse block view. We'll get context, which I think I have. I do. Then we would need to have token view block tokens is token view from token array, and this would be results tokens. So block tokens and then result value, and we can get rid of the this array. What else do you want? Right, you want the source range. Okay. Do I have it on the macro somehow? I mean, So let's just take replacement source range, maybe. That would be macro replacement source range. Okay. What's wrong here? That's okay. And that's okay. Good. So now, if we are extremely lucky, this stuff will actually work. But you never know. And it does. Okay, great. That definitely deserves a commit. So episode 150, support non-hygienic macro expansion. I'll still need to think about it, but I wanted to make some progress on the video. So that's what we are doing. We now have the function, and I wanted to do a couple more of those. In particular, again, you didn't like in this version that we have no way to specify that I want constant value. Right now we don't support constant values at all inside the compiler, but I do want to do it, and if I want to do it, I need to be able to specify them somehow. So this is what I'm going to do next, and this is how it's going to look like. I will say const, and then name, then equal, and we will just create a simple transform here. We'll say const, and in here I actually don't particularly care what happens. Then I want an equal, and then I want again so this is like kind of binding, and this is value or expression. Now I can do what I did before, where I say like so, and name, actually this will be binding equals expression. Let's call it, let's make it full one. Right. So the question is, will that also work, or there are some problems with it? Let's try to run the tests and see. No, that works perfectly. Right. So this count is a constant one, but this internal one is actually mutable. And for now, I will map them to exactly the same thing, but I want to have a mutable keyword. So that will be exactly the same thing. So now we have mute count, and we also will have for mute temp is integer. That's actually kind of interesting. I need to see if that actually works. It should, but yeah, that needs to. It's an interesting thing. Let's try to run these now. Everything works great. So we have constant this, constant that, and I'm thinking also to be very explicit about stack, because what we are saying here to the compiler as developers, and actually to other users as well, is that I don't particularly care where this is stored. I promise not to change this value. But yeah, I don't care where it's stored. In here, I want to be explicit and say, I actually do care where it's stored. I want it to be specifically on the stack. I don't know if it's going to be actually good or bad. Maybe this is one of those things like C dot and arrow, which is just going to be annoying in the long term, but I want to try it out. In worst case, this will be like this at some point, but I want to try with a more explicit version first. Next is a question about how to specify the type, and I think I want to get rid of necessity for a colon here, although maybe it's still a good idea because in a function for now there will be one, but this is not something I will be able to change in a macro at the moment because I don't have variadic macros, but I think I also want to switch to a Go style declaration where you just have a type as a second thing coming after the name in the argument. But for now, that's just not something I can do. Okay. So yeah, stack. Let's do stack. This will be one name, and then type. So we will have name, then colon, and then type. Let's try that. Okay, that seems to be just fine as well. This is a constant. Okay, so this one. This is what I said. I want to explicitly have a distinction between constants and statics. And this is a static variable, right? We are just saying that it is going to be a global, and this is the value for the global. And in a sense, I want all the combinations to be available. So I would want to support something like static mute at some point, where it is global and it is mutable. But by default, I would say that static will imply constants, and I can't really do anything about it anyway at the moment because I only have statics as constants. But anyhow, binding, and then we have colon, and then we have expression, and this is basically the same as the constant mute. So these two, except that it maps to this stuff. Binding and then expression. Right. Actually, here it's also equals. Let's see. Undefined variable integer. Interesting. At 1419. So wait, is it unhappy about this stuff? Huh. That's interesting. So I think there is some problem in the tokenizer, I guess, but that's a separate thing. It has nothing to do with what we are doing at the moment. Okay, we have minus code, that seems all okay. We have mute integer index, and these ones can be const, and this one is static. Right. So these are basically the changes. Let's try again with test. Everything works out. So this is the new syntax that I'm considering. And yes, I had to slightly hack how macro setup works, and I still need to think about maybe there is a better way to do the rewrites on a token level. But this is this is not too bad, honestly. It's very concise and very sort of nice. And I'm pretty happy how this worked out. Again, I'm not 100% sure about this syntax in particular, but I think it is the direction I will be going, because I kind of like how it looks, and it's a bit more compact for the procedures. So yeah, that is that. I hope you enjoyed the video. I hope you learned something new. If you have any questions, I will be happy to answer them. Just leave them in the comments down below, and I will try to get them as fast as I can. Thank you very much for watching, and hopefully see you next time.